So thanks everyone for tuning in, and I'm going to talk about building a fantasy game console with C#, Lua, and Rider. And before I dig into this, this is a project I've been doing for the past 4+ years now, and it's like a lot of hobby projects. It's something that I pour all of my free time in at nights and weekends, in between flights, and a lot of sleepless nights. And today I'm glad to show a lot of the stuff that I'm working on, because it's been a really long time building it, and there's a really good feedback from people. And one of the things I want to make sure that everyone can walk away from is just learning sort of the things that I've learned over the past few years building this kind of game console. So a little bit about myself and my background. So I am a chief evangelist at a company called Missing Link AI. So my day job is working with AI first companies, doing computer vision and deep learning, and we build solutions that help automate their workflow. I have over 20+ years of enterprise development. I've worked for companies such as MLB, HBO, New York Jets, Bloomberg, and more when I was a web consultant. I also worked for Microsoft and Amazon, and I doing 8 years of game evangelism. And that's sort of what fed into this. And I've had a varying career of doing web development, native app development, game development, and currently I'm going into AI. And a lot of the stuff that I'm doing in Pixel Vision 8 is sort of what were the seeds that got me interested in it. But this talk really isn't about current Jesse. It's actually about old Jesse. And when we think about the word nostalgia, it brings up a lot of things. For me, I spent the past few years really trying to understand what made me happy as a child and the things that I loved, and went through some interesting times buying everything I could on eBay, from old game consoles to old games that I loved, and trying to scratch an itch that I didn't think I really could scratch. And when I really think back to it, one of the things that I just wanted to capture, and I didn't even know if it was possible, is could I actually go back to the time where I was a kid and the magic of computers? And if you talk to a lot of people who do hobbies or side projects, it's interesting to do stuff for love, but what winds up happening is that if you attach any money to it, it winds up going from a passion project to a business. And sometimes a lot of the fun can be sucked out of that. And what I've noticed over the years is that my love for making games has dwindled as I tried to become more and more successful at it. And the more I failed at it, the more frustrated I got. And I really lost that love. But if you close your eyes and you think back to what are your earliest memories of a computer, and for me it was in the early 80s, using an Apple IIe. I was a big Macintosh person when the Macintosh came out, and my first home computer was a Macintosh LC. It was the first color computer I think I'd ever seen, and it stuck in me so much that to this day, I love the old feeling of computers, the rough edges around them, the amount of knowledge you needed just to get up and running, and it's something that's totally missing now from the current generation. So about 5 years ago, I discovered this thing called Pico8, and Pico8 is the grandfather of fantasy consoles. And what Pico8 did was it actually rekindled that love that I had for playing with computers, and it did it in a very unique way. Now, I've worked with lots of game engines over the years. I've written a bunch myself. I have done tons and tons of courses on Lynda about how to build games. But what Pico8 really did was it distilled my childhood love for 8-bit games and really added a lot of restrictions that forced you to be creative, just like you had to be on these old game consoles. And to give you a little bit of context, these are some screenshots from what Pico8 is. It's a very simple program. It's only 128 pixels by 128 pixels. And it consists of 5 tools. There's a code editor, there's a sprite editor, there's a sound editor, there's a tile map editor, and then of course there's a music editor. And with these 5 tools, it's actually enough to sort of build, I wouldn't even say simple, but very just fun little games. And there's a huge community around Pico8, And early on, it really inspired me to start, figuring out like, what do I really want to do as my next project? And to do that, I had to understand the idea of what a fantasy console was. And this is what really fascinated with myself with this concept. They're self-contained development environments. Basically, it has all the tools it needs in order to allow you to build games and run the games from scratch. There's very strict limitations. Pico8, again, the resolution is only 128 by 128. There's a lot of restrictions on memory, color palettes, stuff like that. And then a unique ecosystem, just like the consoles that I played as a child growing up, all had a unique feel. Nintendo games felt like Nintendo games. Sega Master games felt like Sega games. Each of these fantasy consoles that have sprung up over the years now all have a very unique look and feel. So the one thing that really bothered me about Pico8 was this. This is basically what you see when you boot it up. And again, as a Mac person, this is very alien to me. I really didn't do a lot of time on DOS. I think maybe in school I had to, but even most of the school stuff that I did was in Macs. And in order to start Pico8, you are presented with a command line. And I just felt like this wasn't intuitive, and it definitely wasn't indicative of my childhood. So it brought me to about 4 years ago building Pixel Vision 8. And there was a lot of things that I wanted to do differently that I felt that Pico8 wasn't doing the way I liked. And over the past like 5 years, so many fantasy consoles have popped up now. There's a huge list of them, but they all really copy Pico8, and they do very subtle differences, maybe a few different colors or different resolution. But for the most part, it's the same story. You start with a command line, you have the same basic tools, and it's a very simplistic experience. So when I set out to build Pixel Vision 8, I really wanted to build a better user experience. And the way that I think about it now is that fantasy consoles, for the most part, are stuck in the DOS era. And I wanted to bring fantasy consoles into the Mac era and introduce what these things can potentially be like based on the same leap from what DOS was like to the original Macintosh. And so to do this, I set about creating a desktop and disk system so that it was a little bit more intuitive and something more familiar to people who are coming into it now who may not have grown up in a time where you had to use the command line in order to do anything. I also was really interested in customizable specs. I felt really limited by Pico8, and I don't know if people are familiar with the game Celeste, but Celeste is a indie darling, a very good game. I think it won a bunch of awards last year, and it's out on the Switch and PC. And Celeste actually started as a game in Pico8, but the developer wanted to turn it into a bigger game, and they couldn't do anything with it once they were done with it. So I really wanted you to be able to customize the specs and grow as your game grew. And that brings me to the last part, is extendability. So from a very early start, and mostly to my detriment of what's taken me 4 years to build this, is that Pixel Vision 8 is completely extendable. I'm going to go over how the OS works and stuff like that in a little bit more detail, but you can basically build it from scratch. You can use the source code, and you can actually modify the source code and build your own fantasy console if you wanted to on top of Pixel Vision 8, or go your own direction. So I wanted it to be as open as possible, and even more important is that you can build your own tools. So with that, I want to spend a little bit of time just talking about how to actually build Pixel Vision 8, and I'll go through what Pixel Vision 8 actually looks like. So we'll get started with just launching this build I have of Pixel Vision 8. As it launches up, it goes into a pretty standard boot screen. And right now, this is sort of where I differ from the other fantasy consoles. So I was hoping to get a cleaner build ready in time for this talk, but one of the problems was that it just takes a lot of time. So as a side project, I didn't get as much time. In fact, let me actually restart this real quick, and I'll hold down the 2 key, which I don't think I have a big enough resolution. So hopefully you guys can see it well enough. I capped the resolution so you can scale it up or go full screen, but I think because I'm running on a lower resolution now, it's not going to work. But as you can see, this boots up and it tells you that it can't find a game to run. So my idea of a fantasy console is more like an emulator. So this Pixel Vision 8 executable is the actual VM or fake VM of what this console would have been like in the 80s. And just like I grew up, it didn't do anything until you inserted a disk or you put in a game. So I have a folder of disks that I'll sort of walk through real quick, and I can drop a game on it. But what I'll do is I'm just going to drop this Pixel Vision OS disk. And what we'll see is that it boots up into the desktop because it's literally booting off of this disk. If we open up the disk, there's an installer. I have a build of this that actually gives you a hard drive, so you can install the OS on the hard drive and not have to swap out disks. There's some demos. I can show you a quick demo. Just as an example, here is a tile map demo that I built really early on. As you can see here, it's emulating Game Boy resolution and Game Boy graphics, but it's just going through and rendering out the tile map. And one of the things that Pixel Vision 8 does, it's a lot different than modern game engines, is that it's using hardware sprites. And the idea is that you have a set number of sprites. So the little diamond number that's going between 29 and 30 is telling you the amount of sprites that are on the screen. A Game Boy could only run 44 sprites at once, or I believe 40. And the one on the right is the frame rate, which is just running a little bit low right now, probably because of the capturing. So, and there's a lot of other things going on in this demo, but this is as close as I can do to simulating what the original hardware of like a Game Boy would be like. And I use the word simulating, it's not emulating. It's just creating a situation that acts just like some of the hardware specs that I wanted to reproduce. So there's a full file system. Also, you can put games on. So I'll show you the first game that I built with Pixel Vision 8. I'm a big fan of Ludum Dare, which is a 48-hour game jam. And this is a game that I built called Reaper Boy. And it's a pretty simple game. Your goal is to use gravity to basically crush bad guys and not die, which I did. And this, again, because early on when I was building Pixel Vision 8, I was still emulating other systems, and I didn't really have a lot of design in place in order to give it its character. So I started working with a new artist halfway through the project. Her name is Cass Pixel on Twitter, and I highly suggest following her. She does amazing work. She created all of the UI and everything you see here. And we went through and we were like, well, what would be the Mario? What would be the quintessential game for Pixel Vision 8? And we went back over and redid Reaper Boy, and she came up with a beautiful 16-color palette. And as you can see, it's a very similar game, and I died immediately, but we're pushing the graphics a lot more. But the important thing to note is that technically, with the exception of the amount of colors that this would run, this could have actually run on a Nintendo. So Nintendo was limited to 3 colors per sprite, and here I'm using 8. But everything else is the same as 8-bit hardware. It's all sprite-based. Even the fonts and the graphics are all being done with tricks in the tile map and swapping between the tile map and sprites and stuff like that. So that at a high level gives you an idea of sort of the games, but the real magic of Pixel Vision 8 happens when we start adding tools. So the core of it is free, and I'm working on open sourcing more of it, but there's 3 different features that I sell that are just for adding more tools to it. And one of them is the draw disk. And what I have here is that it gives you the ability to create color palettes. You can actually drag and drop these around. And if you look back to the picture I showed of Pico8, these tools I'm trying to build are a lot more advanced than what the other fantasy consoles are doing. I just really wanted this to be as Mac-like and friendly as possible, and as close to current tools as you would get. The sprite tool is very similar. You can go through, and it has full painting tools, and a lot of these algorithms are the same algorithm that were used in like early Mac Paint. And I'll swap out another disk, and I'll just show you the music tools. Now, these are the ones that we worked a lot on, and I'm really, really proud of these, mostly because one of the challenges that I have is my background's in art and programming now, but I really have no musical talent. And all of this is generative music. So this is using a thing called SFXer, and there are all these different sound templates, and you can basically go through and generate your own sound templates or tweak them manually. But the really cool thing, and sort of what has been inspiring me to get more and more into machine learning, is this tool, the music tool. Now, on the surface, this is a pretty standard looking tracker. You can go through and you can play through all the notes and everything, and I don't have the volume up, but it sounds as 8-bit chiptune would sound. But this button right here is really special. And this is something I worked with someone named Krister. He goes by McFunkyPants on Twitter. And if you click on this, it actually randomly generates new songs. And this was something that I had really wanted to work on. And I want to expand. It's that these tools also help people who aren't really that inclined in the arts or music. Like I would love to get sprite generators and other kinds of things going and really dig into this whole world of generative computer art that's happening because of AI and deep learning. So, and all of this is configurable, so you can go in and configure all the parameters that generate the music. And the last thing I'll show of Pixel Vision 8 before I start getting into the code is the make disk. And what's really powerful about this is that it gives you all the tools you need to export the games. And this is something that I'm actually working on for the next release, which I'm hoping to get out later this month. So you're sort of seeing this in a raw state. But if you click on the data file now for the game, you'll see this chip or this board with all these chips in it. And what you can do is click on the cart and select template. So here I'm using a Pixel Vision 8 cart. I can click on the GPU and I'll drag over the Family cart, which is basically a Nintendo. And for sound, I'll drag over the Game Boy chip. And what I've done is I've actually created my own custom fantasy console. It's using Pixel Vision 8's cart sizes. It's using the GPU from a Nintendo and the sound chip from a Game Boy. And again, these are simulations, so it's just some core values that I restrict. But you can do all kinds of stuff. In fact, if I wanted to, I can change the GPU graphics into CGA graphics. And you'll see here that it'll change the resolution to 328 by 208. It also changes the color palette as well. And there's a lot of different chips and templates that we've been working on because I really wanted you to be able to configure this as much as you want. Or even more important is that if you're building a game and let's say you need, you want to do a smaller game size, you can go in and customize it. And when you're done, it'll just give you a custom chip and you can save this template out and share it with others. So that at a high level is just what Pixel Vision 8 is and sort of what fantasy consoles are in general. And I spent the other thing I could show, which is a nice bit of nostalgia if you come from the Mac era, is that you have to also shut it down. And you can just do that from the menu. So one of the big challenges with this is how do you architect a system that is this flexible? And what I wanted to do is I'll show you here on GitHub is that all of the source code, with the exception of like the premium tools, are all on here. And the reason why the premium tools aren't open source, outside of needing to help support the project and pay for these great artists and coders that I work with, is that you can actually use your own external tools too. So it's designed as modular as you want, but it really comes down to there are two main projects here, and the two main projects are the Pixel Vision 8 source code and then the Pixel Vision OS. And for some reason my mouse hid. Oh, there we go. I got it back. So this is all the code we need to run the project, and this is the operating system itself. Now, when you come to the project, the master branch, at least right now, the master branch is usually the most up-to-date, so this is the last release. But I've been working on a new release for the past 2 months, so I'm going to go down to the 1.9.4 feature, which actually has a completely restructured project, and I'm going to go through all the source code. But if you wanted to try this after the talk, my suggestion is to go, if you go to the branches, those are going to be like the nightly builds, whatever the last branch is, and I always make sure to put master in as the most stable build. The same thing for the OS. There have been different versions of the OS, so currently I'm working on 2.4.0 of the OS, and this will give you sort of what I'm showing today. Now, I've gone ahead and I've already downloaded this, and what I'll do is I'll just unzip the source code and unzip the OS. And once you unzip the OS, all you need to do is you can just remove this tail end and just call it Pixel Vision OS. This entire OS is actually written in Lua, and I'll sort of explain how this works under the hood. But the really cool stuff is in the source code here. So in the Pixel Vision 8 project are two solutions that you can run. So the first one I'm going to run is just called the MonoGame runner. And the idea of how I architected Pixel Vision 8 is around these concepts of a runner. A runner basically wraps the software renderer that is Pixel Vision 8, and it allows you to run it on a computer. So it bridges the gap between the software renderer and the hardware it needs to run. So I try to keep the project pretty clean. So when you download it, I don't include any of the built-in runs. So if you download this from scratch, you just need to go into the configurations, and here I'm going to create just two builds real quick. One I'm going to call C# runner, and then I'll just duplicate this and call this Lua runner, and I'll just switch over to the Lua runner project and hit apply. So I want to show this off real quick, and then I'll get into the code. But if I just hit run, this is going to give you the most vanilla, bare bones version of Pixel Vision 8 you can get. Right now, it's just going to load up one little game. It's the default template. And I'm going to load up the Lua one as well. And we'll let that build. And I'll show you what they look like side by side. And as you can see, they're exactly identical. What's interesting is that the C# one has a set of pure APIs. There's a game chip, which I'll talk about in a minute. And the game chip exposes a set of APIs that you can use for drawing text, rendering the background, doing some advanced stuff with caching graphics, or just writing directly into the display memory buffer. The Lua side, however, is using something called Moonsharp, which is a C# interpreted Lua VM. And that layer sits on top of the C# code and exposes all the C# APIs to Lua. So in essence, when you build a game in Lua, you trade off a little bit on performance, but what you gain is the ability to not have to recompile your game every time, and you can use Lua as a scripting language. Everything else under the hood, how they load assets, how they parse assets, everything is done all in pure C#, and it's exactly the same. So that being said, let me jump in real quick, and I'll just show you how this project is set up. We'll go into presentation mode, and let's just toggle real quick here. There's a folder here called shared, and in it are these two shared folders. One of them is the pure SDK, which is broken up into the engine. So this is the core Pixel Vision 8 engine, and then there's the runner. The runner, again, is what's going to bridge the software renderer and the software VM into hardware, and so it can run on your computer. And this runner is all the glue code that ties into MonoGame to get Pixel Vision 8 to run. So originally, when I started this project, it was actually a Unity project, and I ran into lots and lots of problems. Unity didn't like the idea of me just rendering to a texture at a consistent frame rate. And over different versions of Unity, I was running into other issues, a lot of bugs. I used to have a web GL build going, but then it broke, and a lot of headaches. So eventually I decided that I just wanted to go to the pure source code of running this, and that's how I switched over to MonoGame. And I'll show you how I implemented that a little later on. But the runner just gives you a lot of stuff that ties directly into MonoGame. But the real trick of how Pixel Vision 8 works and the simplicity of it is in the architecture. So there is a main Pixel Vision engine, and this is the class that actually runs the game. And the way that the engine works is that you need to pass it in a collection of chips. You create a loop, and the loop will call update on the game, it'll call draw on the game, and when it loads a game, it'll call init. Other than that, this engine just handles taking everything from all the game chips, merging them down, and then putting them into the runner so that the runner can actually display what's going on. The way that I do this is through these notions of chips, and each part of the game engine is completely modular. So there's a set of audio chips. So I have a music chip. I have an SFXer music chip. So the sound engine now is using SFXer. Eventually, I'd like to get it over to something that's a little bit more authentic. But again, these are all swappable, so I can swap out any of these chips that I want. As you can see, there's a music chip here, but it's using the SFXer music chip. And the same thing with the sound chip. There's a sound chip here and an SFXer sound chip. There's a game chip, and this is the core of what actually plays the game. But it's a class that exposes a collection of APIs to you. to make working with the game a lot easier. So as we scroll through here, there are APIs for graphics, allow you to make new canvases. There's some debug things like getting the frame rate. There are game chip properties, which allow you to save. And this goes on and on. A lot of stuff like display, you can get the width and the height of the display. You can clear the display on each frame. And so the game chip really gives you the API of what Pixel Vision 8 does. When you're in C#, I'll show you an example of it. If you wanted to make your own custom game, you simply extend this, and then you write your own code. Then there's graphic chips, so chips that manage color, the display chip. So the display is a software renderer. Basically, it takes color indexes and creates one big array that represents the display, and then the runner will go through, read the display chip, and convert that into colors. There's also a font chip for managing fonts, a sprite chip for the sprites, and a tile map chip. And then finally, there's some other chips just for controller input, and that needs to be tied in from the runner. So the runner is responsible for not only just outputting from Pixel Vision 8, but also capturing input from it. So, and the Lua engine, the Lua side of it is actually just a special runner that sits on top of it that initializes the Lua VM. It exposes a few things to Moonsharp. If I actually go in here, you can see Moonsharp has this notion of creating a script, and in the script you can give it a global variable. And what I do is I expose functions or methods from the runner to the global scope of the Lua script. So here I'm setting the volume, and I'm using the runner's volume function, and I'm using a delegator here just to pass through. And so that means that whenever I call a volume on as a global function in Lua, it'll be made available. So here are just a few of the runner-specific things that I'm exposing. And the game for the Lua side of things is just its own custom game chip. Here it's a Lua game, it's extending the game chip, and the only thing that it does is it handles a few different delegators for passing things back and forth between the Lua side and the C# side. But mostly what it's involved in doing is just simply calling a global init, update, and draw, which you define in your Lua script. And so I'll show a little bit of how this works in more. It's a little abstract if you're new to sort of trying to map out sort of a native API over to Lua, but it's incredibly powerful, and there's very, very little performance hit that you get. A lot of it, because it's going purely to C#, it's just passing data back and forth. So a lot of the performance hits you get is in reflection from Lua. So I try to use native types as much as possible, so it doesn't have to do a lot of reflection. And there's all kinds of different optimizations you can do. I've spent a lot of time going through and trying to optimize it. So at its core, if we just look at the program that runs the C# runner, it's really simple. Here, I just define a new C# runner, and I tell it to run. And the only thing I pass in is a path to the files that it needs. So in the content folder, I have a reference because I'm sharing these between the two projects. The code actually I don't need, but there's a colors file, a data file, an info file, and a font file. And that's all this game actually needs to work. And again, I designed this so that you can use external editors. So if you're just doing the C# side of things, you can just open up the colors PNG inside of Photoshop or Aseprite, and it's just a single pixel of each color that the game engine uses for the color. The data is a JSON file that defines the specs of the system. Info is some metadata, and then the font is just its own graphic. It's a sprite font. So what happens is the C# runner will go through and just automatically get a list of chips. So I define the chips that I need. It initializes itself, and then it tries to just load the default game. And here I just go through whatever this folder is of content and filter out anything that says PNG and JSON. It goes through, passes it, and then it tells Pixel Vision 8 to process the files. And once it processes the files, that's what actually gets everything into the game engine. And in the SDK, what you wind up having is there's a set of services. And so services is a layer that allows you to communicate between different chips. And there's one main service that's used, which is the load service. And the load service allows you to go through and load all kinds of files. And it uses a collection of parsers. So again, I tried to make this as modular as possible so you can actually create your own different load service if you wanted to change sort of the structure. Like I've been playing around a lot with the idea of maybe switching from PNGs to GIFs because GIFs already have the color palette built in. So I could write a different load service that can do that. But each one of these parsers handles a very specific task, and they all extend from an abstract parser. And these are, it's a pretty basic concept of just setting up a way of calculating how many steps it needs to do and going through the steps of actually doing the parsing. So a big thing that I did a few refactorings ago was make all of this multi-threaded so that loading games happens really quick. So that's sort of like a high level of how this stuff works. And what I want to do next is I'll show you how to actually build Pixel Vision 8 and go into a little bit more of the architecture of that. So the other solution that is in this project is the Pixel Vision 8 runner. And I'll just load this up and we'll take a look at what the what's inside of it. So it's going to take a little bit for it to go through and parse everything. There are two main projects in it. There's a game runner. The game runner is sort of like the vanilla version of the Pixel Vision 8 runner, but it has a lot more of the Pixel Vision 8 specific APIs that I'll talk about built in. This is the template that I use for when you export a game from Pixel Vision 8 as a native exe. So there's a lot of stuff that I strip out. So like the editors or the file system isn't really critical when you're running a game. So I wanted the games to be very sandboxed. So if you just wanted to take a game that you are working on in Lua, you can dump it into this game runner, and you can actually extend the game runner if you wanted to give the Lua side a little some more APIs. The other side is the Pixel Vision 8 runner, which is the core of what I showed you earlier on when I actually compiled or when I actually ran Pixel Vision 8. So I'm just going to call this Pixel Vision 8, and I'll switch to the Pixel Vision 8 project, hit apply, and from here I'm just going to run it in debug mode. So while this goes through and boots up, you'll see a bunch of warnings. It's been a while since I've had a chance to really go through and clean up this code, but what's going to happen is it's actually going to boot up, and it should boot right into the OS because previously it had remembered what we were doing. So there's a shared file between between Pixel Vision 8, the exes, and if I actually go here into the shared folder, I can delete the previously created user BIOS, rerun this, and you'll see it'll be restored back to its default state. So if you're downloading this right off of GitHub and you set up the build and you just compile it, you're going to be presented with this pure version of Pixel Vision 8. And just like I was saying earlier, all you need to do is take the version of Pixel Vision OS that I downloaded earlier, drag it on top, and you're now inside of Pixel Vision 8. So, and this is the same experience you get with any of the versions of Pixel Vision 8. Now, there's a little bit more going on under the hood, and I'll talk about why this build of the project is a little bit more special. So if we look in the shared folder, there's a similar structure you'll see as before. We have the Lua APIs, we have the core SDK, but we now have a new project or a new shared library called the Workspace. And the Workspace actually contains the file system that Pixel Vision 8 uses in order to load stuff up. So as I was mentioning earlier, the previous runners, you would just sort of get a list of files in their binary form and pass it to the loader and it would go. Pixel Vision 8 proper, however, actually uses a complete file system. It's a virtual file system, and it has mount points. It actually is mounting those disks to a root. It has a whole set of APIs for going through and opening files, reading files, and it sandboxes that to keep it protected. So in this workspace, there's just a runner and there's a custom desktop runner, which is what bridges the desktop file system to Pixel Vision 8. There is also a new project that I've been working on called this package creator. And what the package creator does is it allows you to build out different versions of Pixel Vision 8 for different platforms. So what I'll do is I'll exit presentation mode, and I'm going to switch over to the release build, and I'm going to hit release. And while this is going on, what I'll do is I'll go inside of the project, we'll go to the runners, we'll go to Pixel Vision 8, go into bin, desktop GL, it's going to boot up in the background and release. And what the packager has done now is it's created 3 different zip files, and inside of these zip files are the are basically executables that I can upload now to different places where I distribute Pixel Vision 8. So I just open up the Mac one, and I can just run this, and you now have a build. Now, why am I showing you this? Well, one of the reasons that I started out with Unity was because I wanted to take advantage of the cross-compiling that Unity did. So I traded off a lot of performance for the ability to just hit compile and have it go. When I switched over to MonoGame, I was really surprised by the fact that there is no way to actually bundle up a package game once it's exported. So in the debug folder, this is what you get. It basically generates out just a Windows version of the game. And while you can sort of run this on the Mac, it needs to do some very specific packaging. So I worked with a developer who created a packaging solution that was based on another packaging solution, and I've sort of been modifying it over the past few months, and now I'm sort of including it in here because I wanted to be able to make it easier for you to output the different builds of Pixel Vision 8. So that's one note that I have to say, like going from something like Unity over to MonoGame, I've had to do a lot of custom work in order to get MonoGame to work. And in fact, in what I've done here is, I'll go back in the presentation mode so you can see it a little easier. But I actually have a custom build of MonoGame at this point. So this is called MonoVision, and it's API-wise exactly the same as MonoGame. So I want to support full backwards compatibility with MonoGame. So the other project I showed you was just the pure C# and Lua runners. Those are just using NuGet packages for MonoGame. What I've actually done in this project is that these 2 runners are using a custom build of MonoGame, and I stripped out everything that I don't use. So all the 3D stuff, all the shader stuff, bones, whatever, like MonoGame is a monolith. There's a lot of stuff in there. And I've even gone through and optimized the renderer and streamlined it specifically towards running Pixel Vision 8. So this is going to give you the best performance possible. And if you needed to fall back to MonoGame, you can always do that because, again, I haven't touched APIs. I simply stripped out things that weren't used. And then the last thing I'll just go through and sort of talk about the structure of how Pixel Vision 8 runner actually works is that there's a program just like we were talking about before, but the difference here is that this is actually going to create the root and pass it in, but we're using this new Pixel Vision 8 runner. And in the runner folder, you'll see there's a Pixel Vision 8 runner, and this does everything that's needed to create the file system, to create the editors and the underlying editing system that you need for the tools to work. There's export services. So earlier I talked about the load services. There's a special load service here that does a little bit more because it accepts a lot more data than the standard vanilla build of Pixel Vision 8. A lot of stuff that just goes into how to run Pixel Vision proper. And then there's an export service. And in the export service are all the things that the tools are using, such as being able to export color palettes, images, the music exporter, PNG writer, stuff like that. There's editors, so there's a game editor. This is what allows the tools to actually edit other games, and some custom audio stuff that I've been working on too, such as the music generator. So all that said and done, basically, there's a lot of stuff going on in here, and I'm thinking back over all the years that I've spent sort of like refining it and refactoring it and working on it. And one of the things that hasn't changed over the years is this architectural approach of creating stuff that's incredibly modular. And I talked about my background sort of in software development. I built really big enterprise apps, and one of the things that we always struggled to do was just keep things really simple and modular. And a lot of the times, what I've learned from building these apps, especially when you're in really large teams, is that not all the stuff is going to be built at the same time. So I had really strong ideas for how I wanted like the core services to work or the chips to work, but I had to use interfaces and a lot of dummy code to keep things going until I actually had like a fully functional build to Pixel Vision 8. And because of this, very little has changed in the core of the engine. A lot of the past 2 years has really been moving off of Unity and into MonoGame and streamlining and optimizing it. I think maybe the only thing I've changed API-wise from the early days was just the music API that I've been adding in for this next release. And it's one thing that I've been impressed with for myself, that I was able to like think this through and really create a clean thing. Now, the runner side of it is a complete mess. The runner is taking a lot of time. There's a lot of refactoring, and there's a lot more coding that needs to go into it. So the last thing that I wanted to really go over, and I'll talk a little bit about the Lua stuff, because the architecture for the OS is also really simple if you once you understand it. So I really wanted to challenge myself to build this sort of OS completely in Lua. And there's a lot going on. It wasn't easy. I had to build a whole framework system for all the UI and everything that you see. What I want to do real quick is let me get into the downloads folder. I'll open up the OS. And one thing I want to do is open up Atom. So I'd mentioned earlier, like one of the reasons why I don't bundle in all the tools. So I'm a big believer in letting you use the tools that you like to use. Why should I tell you what tools you want to do? And especially like who wants to edit code? Like if I go in here and I look at this like info file, even at 256 by 256, this text editor is like really tough to use. And while I still need to go through and fix a lot of the stuff in the text editor, I would rather use something like Atom. And in fact, I've actually built a plugin that allows you to go through and get code hinting for Pixel Vision 8. And what I'll do is I'll just load this up into Atom. And it's allowed me to be a lot more productive, especially when I didn't have the tools working in place. So to me, the core concept of what this OS is just to give you like this file system and a place to work, but that you can either mix and match, either use the built-in tools, especially stuff like the tile map editor, which is very custom to this, or the sound tools, and then use your own art tools or your own text editor on the other stuff. As you can see here, there's a few things that I'll point out, and I'll talk about how the tools work. It might be easier to see it here. In fact, let me see real quick, see if I can scale this up a little bit. Nope, the resolution is a little too small. So sorry about that. I was trying to find that right balance between being able to stream this and not kill everyone's bandwidth. But you can definitely make this a lot bigger. It just depends on what you're doing. So if I go through here and I look at the system folder, so if you, inside of a disk, if you create a system folder, you'll see it has these stripes. That lets you know that Pixel Vision 8 is going to read this folder. And there's a libs folder. This allows you to have all the libraries. So these are all the library files that run Pixel Vision 8. So there's a lot of interesting stuff in here. This one, for example, is the UI picker. And these files are pretty big. There's even in the built-in one a little line editor, or you can actually see the lines of code. But if I go into the file picker here, you'll see that this right here is actually its own game. And as I talked about earlier, there's just a basic init method. Now this is probably a pretty bad example to show off because one, it's really small, but two, it's about 2,000 some odd lines of code. And this is the core file system. But the way that Pixel Vision 8 actually works is that you can have shared libraries. They're individual Lua files that sit in a libs folder. And anything you have in a system tools folder will automatically get scanned and converted into a tool. So the way that, for example, the image preview tool works, if I look at its info file, it's registered with any type of PNG. So as long as it finds a PNG file, it will open up the image editor. And the thing that actually keep in mind, in fact, here I can show you what the image editor looks like. Here, it's just previewing some fonts. I think the big paradigm shift I did in the beginning when I built Pixel Vision 8 was that I rethought how the OS should be. And this is why it's so modular, is that every tool that you see, including the OS, the boot tool, the load tool, all of these things are actually just games. And one game can load another game. So all the file picker is doing is that once it sees that you want to open up an image, for example, so the file picker is responsible for looking for what tools are registered, opening up the right tools. But once you open it up, all this is doing is telling it to load a game, just like you would with anything else. So the game I showed you earlier on, Reaper Boy, is actually 2 disks, and it's one game loading another disk, and it goes back and forth. And the same concept is here. So this is what allows you to build your own tools to extend it. So if you wanted to build your own sprite editor, you could, or you can take the code from my sprite editor and modify it. One of the things I'm working on for the next release is this idea of being able to have installers. So I was mentioning having a hard drive. I noticed it was a little bit buggy earlier when I was trying to do it. I'll run it and it'll take me I'll have to restart a few times because I haven't finished the code yet. But here's an installer. It allows you to go through and you define all the files you want. I'm going to click OK. It's going to break a little bit because there's no workspace. I think I have to install it twice and restart Pixel Vision 8. So you'll see here is a workspace, and in it, it's going to create the files it needs. So it's just copied this entire disk over, but once I exit this and restart it, it'll give me a little bit of an error, and I'll just reboot it. But these are kind of the more modular things that I'm going for, and I have to say, like, one of the biggest challenges that I face with building it, outside of the fact that I have no deadlines, I just do what I feel is right, is trying to find that balance between what is authentic. To me, the disk system and dragging and dropping is authentic, but what is also fun and easy to use. And it's something I'm interested in finding out from people. Do you really want to install a operating system from scratch? Do you want that level of granularity when building Pixel Vision 8 from the ground up? Or should Pixel Vision 8 just start with a Finder? To me, I think that it's, from my childhood, I spent a lot of time building computers, reinstalling them, understanding how the operating system worked, tinkering, and I wanted to capture that. Unfortunately, I just don't think that that's something that a lot of people do these days. So here you can see it's now installed, and I changed the background so I know when it's installed, but now everything is running off of the workspace. So if I loaded up different disks and different tools, they would also show up and work. And to point out sort of how this is actually working, if I go into this folder in my documents folder called Pixel Vision 8, you'll see here's the workspace, and the same folders that you see here are actually here. So if I create a new folder called Hello World, you'll see that it pops up here, and it should refresh in a minute and give you a new, I don't know if renaming it there's a refresh time, but I can always hit Control 4 and rename it. In fact, what I could do, even just to show you how you can work between Pixel Vision 8 as a fantasy console and on your system, is if I create a new project here, and we take a look, we'll see here's the new project, and I'll open up the new project, and I'll put these side by side. If I run this game, you'll see here's the empty template that we saw earlier. If I open this up in Lua and change this to Hello World, save it, go back into Pixel Vision 8 and hit Control 4, it'll automatically refresh and show you the latest code. So that's sort of the workflow that I do, and I wanted it to be really open. I wanted anyone to be able to come and approach it from a place that they felt comfortable, whether it's your first time using something like this and you wanted to do all the tools and you wanted to have a drag and drop friendly system. Again, even everything in here is fully drag and drop now. So if I wanted to delete this Hello World folder, I can drag it to the trash. And in the template folder, I can move things around. Let's say I wanted to copy a different template up a level, I can copy it to the root. even go to the trash. So if you're used to this as your only introduction to computers, then have fun and everything you need will be here. But the other part, and where I really spent a lot of time architecting it to be modular, was allowing anyone to sort of use the tools that they want. So I think that's sort of it. What I will say is that you can go to the website. It's pixelvision8.com. I am trying to do a lot more stuff for free. Like, the only thing that I charge for really is the time of other developers that I hire. I'm a really big believer in supporting indie developers. It's something I've done for the past 8 years working at Microsoft and Amazon, and I've worked with some incredible indie developers over the years. So it's basically donationware, like paying for the higher tier tools just allows those developers to get paid. And if you join what I call the Fantasy Console Club, you can join for free, and you get a free copy of Pixel Vision 8. So there's a new build that I hope to have out later this month. And then there's a pro tier too, and there's different buying options. But over the next few weeks, I'm going to be cleaning this up because I finally got into a point where I know how I want to package it and distribute it. And I'll be going through and cleaning it up, because it's been in early release now for the past, I want to say, 2 years. And the goal is to have it in beta by the end of the year. And I'm very, very close. I think there's just a few more things I need to fix, like the music API exporting, which I just added in. And then the last thing is cleaning up the tile map tool, and then just general bugs. So that's a lot of my time summed up into a 1-hour talk. And I just wanted to thank everyone for listening to me ramble on about my passion project. And also, you can always email me at makegames@pixelvision8.com. You can follow me, or at least you can follow the game engine on pixelvision8.com, or pixelvision8 on Twitter. And we also have a Discord channel. And if you go to the website, everything is sort of explained on there. The one thing that I'd also say is, too, if you follow me on Twitter, I'm getting into the shift now for deep learning, and there's a lot of really amazing stuff out there, a lot of stuff that I'm doing now, like just as little experiments that I hope to be sharing a lot more with through work. And if you're interested in that stuff, please follow me on Twitter, check me out. I have a Medium as well that I'm starting to post stuff to, and at Missing Link we have an official blog too. So some of the cool stuff that I'm hoping to get done is use machine learning to build a more robust music generator and sound effects generator. I've been playing around a lot with generating out sprites. They don't look very good so far, but I'm hoping to get a little bit better. And just doing other fun stuff like teaching machines to be able to pick out what video game system a screenshot came from and other stuff. So over the next few months, as I ramp up more into that, I'll be sharing that as well. So that is my talk, and I'm looking forward to seeing if anyone has any questions for me.
All right, yeah, thank you. I'm definitely gonna play with this. This looks too fun to not play with, so thanks for that. We do have one question here, basically on whether you could recommend any tutorials or some resources online where people can learn MonoGame from.
Resources and tools for learning MonoGame. So that was one thing that I struggled with a lot. The challenge with MonoGame is that it actually is a extended version of something called XNA, which was an old Microsoft game framework. And trying to find good tutorials on it is a mixed bag, because a lot of it comes up as old XNA stuff, and there's not a lot of good or modern documentation on MonoGame. So I don't have any resources per se, but you know, if you do some Google searches, there are some places out there that might be able to help you, but I struggled a lot with it, and it took me a good month before I really was able to wrap my head around it. And if it wasn't for the help of one of the people in the community who helped do one of the basic, one of the beginning ports, I probably wouldn't have gotten as far as I could. So I think the learning curve for MonoGame is pretty steep, and I wish I had better answer for tutorials for you to to follow.
All right, yeah, I guess that's it. Thank you for closing our JetBrains NET Day Online. I'll have a couple of closing slides as well.
Yep.
But thanks for
having me.